Hello, welcome back. This is our second lesson in learning how to add, multiply, and divide these expressions that involve imaginary numbers. Now, these problems will be more complicated than the last set because we're going to have variables involved. So not only will we have radicals, not only will we have radicals with negative numbers under, so we have imaginary numbers that we'll get from that, but we'll also have regular imaginary numbers running around our expressions and fractions and other things, and we'll also have variables. So it'll be a lot to keep track of, but that's why we're going to do these problems to give you practice. Let's say we have, for instance, negative 12 times a, square root of that, and we're going to multiply that by negative 3 times a. Now, a is a variable. It's some variable. I don't know what it is, but I know it's a variable. Now, a couple things I want to caution you about right at the beginning. We learned, when we're dealing with radicals, we learned that the square root of a times the square root of b, like two radicals multiplied together with different things under the radicals, can be written as the square root of a times b. So for instance, if you have the square root of 3 times the square root of 2, you can write it as the square root of 6 because 3 times 2 is 6. You can combine square roots, in other words. Okay. What I did mention in a previous lesson, but when we first learned this, what we didn't say explicitly is this is really only true if a and b are positive. In other words, this whole combining radicals thing, it really only works if what is under these radicals is positive to begin with. And notice in our problem, we have negatives under the radical, so you can't do it. Don't try to combine radicals together by multiplication under the radical if some of those things are negative, what's under the radical. And that goes into the idea, a lot more into the theory behind radicals and negative numbers and all that. I don't want to get into the real nitty-gritty details of it. But the bottom line is that this was only kind of introduced when we had square roots of positive numbers. So it's perfectly fine as long as you know what's under there is positive. If you might have some negatives under there, then what you have to do instead of that, instead of combining these, like a lot of students will multiply these and say, well, positive, because you multiply this, you get positive 36a squared. This is going to be positive 36a squared. Then you don't have any imaginary numbers anymore. They're gone. Instead, what you have to do is work with this radical and this radical separately and then combine them at the end like this. If you want to do that, then what you should do is go over and figure out what the square root of 12 is. And we've done that many times. We know that that's 3 times 4, and that's 2 times 2. So we circle this, right? So then what you have is the square root of, because it's a negative, comes out as I, and the square root of 12 times a is going to be 2 times the square root of 3 because 2 comes out and you have the square root of 3. However, you still have an a under the radical, so really it's 2 times the square root of 3a. A better way to do that is instead of writing 12 down, really your expression that you're trying to write the factor tree for is really 12 times a. So it's 3 times 4 times a. So you write a factor tree with everything under there except for the negative. Forget about the negative. So 3 times 4 times a, and then of course you have a pair, but the 3 and the a are orphans, so they have to stay under the radical. That's why we have a 3a under there. But because there's a square root of a negative, the I comes out. Then we're going to multiply this by, now we can't simplify this any further, but what's going to happen is I times square root of 3a. Because again, I don't have any pairs. If I do a factor tree, it's going to be 3 times a. There's no pair, so they have to stay underneath. So cleaning this up a little bit, I'm going to write this as 2 times I root 3a times I root 3a. And then you multiply. So what's going to happen is you multiply the I times the I here. The 2 comes along for the ride, I squared. And then you're going to have, let's do it explicitly, 3a times the square root of 3a.